Sometimes it's difficult to measure the insulation resistance on a whole installation, and we have to go through the process of measuring each individual circuit. This is because we can't always isolate the whole of the installation at any one given time. We also know that the minimum resistance of our insulation value is 1 megohm on an installation. Now, of course, if we're measuring separate circuits, we need to carry out a calculation when we finish to make sure that the overall insulation resistance for that system isn't below 1 megohm. Let's just assume, as an example, we've got a situation where we've got 4 circuits. If the first circuit is 2 megohms, we know it's very low, but this is purely a calculation to show you why we need to do a calculation of the whole of the installation when we've finished. Because some installations could have 10, 15, 20 circuits, which of course will reduce the resistance a lot. Second circuit, we can say we've got 3 megohms. Third circuit, let's just say we're back to 2 megohms. And the fourth circuit, let's say we're greater than 200 megohms. We need to carry out a calculation now to see whether that total insulation resistance value is going to be below 1 megohm. The formula we use for working out this type of question would be 1 over R plus 1 over R plus 1 over R plus 1 over R. Now, because we've only got 4 circuits, we've not too much of a problem, but if you want to make sure you get them all, you can number these R1, R2, R3, R4. Equals 1 over R, which will actually equal the total insulation resistance. In this installation, we can see we've got 4 resistance values. All we need to do now is a simple calculation using a scientific calculator to find out the total resistance value of the installation. It's quite a simple process. Firstly, first circuit, 2, and we enter in x to the 1, which we'll find on our calculator, plus 3, x to the 1, plus the third circuit, 2, x to the 1, plus the final circuit, 200, x to the 1, equals, and we'll see it's 1.33. To complete the calculation, we now need to divide that into 1 again. So 1.33 x to the 1 equals 0.75 megohms. So that's the total resistance of my installation. And you can see that although all of these circuits are satisfactory, the installation wouldn't be. That's a good example of why we should be doing this calculation when we're doing periodic inspections and we're carrying out insulation resistance testing.